Hi everyone, my name is Guillermo Garza from team number 4 and my partners are Alex, Mauricio and Julio Cesar. In this video I'm going to talk about the bean packing problem, so let's get started. The bean packing problem is one of the most famous problems in combinatorial optimization. Basically, in this problem we have a defined number of items with a specific weight and an unlimited number of containers with a specific capacity. And the goal or the objective is to save or store all the items in the minimum number of containers. This problem has been studied for several decades, and because of this, new heuristic algorithms have been developed that are more and more accurate. There are some variants of this problem, and this problem it is often associated with the Naxa problem, which we studied in before in the previous classes. But in this problem, the big packing problem, the items doesn't have any value assigned to them. Now we we will check a graphical representation of this problem, and as I mentioned it before, we will have a certain numbers of items with a specific weight and an unlimited number of containers. So here we have the items with different weights and containers with a maximum capacity of 5 units of weight. Now we store the items or we save the items in the containers, uh, and as we can see we have already complete 2 containers, but we still have 1 item left. So we will need to open another container and we need to put the item inside. And here we see the result. We use 3 containers to store all the items. The next thing we will talk about is about the mathematical model of this problem. First of all, we are going to define yj to check if a container is in use. If it's in use, if this variable it will be given the value of 1. If not, the value of the variable is 0 and is the same from the xij to validate if an item is inside of a container. And the objective function is to minimize yj, which, as I mentioned before, is the number of containers used. And we always have to be an item in a container. This is one constraint on minimization. And the last limitation is that the weight of the items in the container may not exceed the capacity of the bin of the container. And this is the complete mathematical model of the bin packing problem. Now we will talk about the real life application of this problem. Mm, maybe you have, maybe or probably you have to solve these kind of problems in one moment of your life, because this problem has many important applications. For example, when you are transporting products on trucks, and another application is if you ever have to save files in a USB or in a hard disk. with a limited capacity. The following the following methods are generally used to solve this type of problem. The first one is known as net fit algorithm, and in this algorithm we will have a number of items and we will store them in the containers in the order in which they were assigned to us. After saving the first item, we will check if the next item can be saved in the same container. If not, we will have to open another container and we will not be able to save another item in the first container. And we will repeat this until there are no more items. Now, in the first fit algorithm, it is possible to recheck the other containers to see if we can save another item. So it's not necessary to open more containers if we have a container with the capacity to store another item. Another algorithm to solve this problem is the best fit algorithm. In this method, we will be filing the containers and we can also check again, like in the previous algorithm, if there is a previous container with available capacity for another items, but we will have to save it in the container that has the least amount of space or the most amount of uh, capacity, but still has mm, but still the container has the capacity of the item we need to save. Next, uh, we can check another methods to solve this problem, but those were the most important ones. For example, we can use the first fit decreasing algorithm or the best fit decreasing algorithm. In these methods, the first thing we have to do is to sort the list of items that were assigned to us, and then it will be up to you to apply the first fit or the best fit algorithm. And that's it.